If you want to win at games of chance, you're going to need to understand probability. When you flip a coin, there are two outcomes, heads or tails. When you roll a die, there are 6 outcomes. 1, 2, 3, 4, 5, 6. But throw a dart at a dartboard. Now things get different. The dart can land anywhere, not just in a few labeled spots, but at any point on the surface. That's infinitely many possibilities. Coins and dice have a finite number of possible outcomes. We call these discrete random variables. The dartboard? That's a continuous situation. We call that a continuous distribution. This means outcomes vary smoothly across a range. There's one subtle exception to the finite idea that we'll talk about later. It's a bit technical, but if you like having the full mathematical picture, we'll go there. Let's return to the coin. There are 2 possible outcomes. If the coin is fair, then the probability of heads is 50%, and the probability of tails is 50%. In math and in code, we usually write those as 0.5 and 0.5. And here's something fundamental. The probabilities must add up to 1, not 1.2, not 0.9, exactly 1. Another way to say this is the sum of the 2 probabilities is always 100%. Let's not be clever and get sidetracked with a debate about whether or not the coin can land on its side. But what if you have a coin that isn't fair? Maybe one side is slightly heavier than the other. This could mean the probability of flipping a heads is 65% instead of 50. Since the probabilities must add up to 100%, we know the odds of flipping a tail must be 35%. We can also write this, more succinctly, as the probability of heads is 0.65. Since probabilities must sum to 1, the probability of tails must be 0.35. That's it. Once you know one, the other is determined. What about your standard 6-sided die? If it's an honest die, then each side has a 1 in 6 chance in a roll. This is a probability of approximately 16.7%, which we can also write as 0.1667. But again, maybe you're a nefarious character and the die is loaded. That means some of the sides are heavier and are more likely to land face down. The opposite side is more likely to face up. Let's say the probability of rolling a 1 is 10%. The odds of rolling a 2 is 15%. The probability of a 3 is 20%. Probability of a 4 is 5%. P of 5 is 12%, and P of 6 is 38%. We wrote this list of probabilities as real numbers and not percentages. People like percentages, but computers prefer regular numbers. There is a 60% chance you are watching this on YouTube, but there's a 100% probability you'd like to learn more. Did you know we have math courses at Socratica.com? You probably did, but just to be sure, click the link below. Can we further generalize what we've just seen? A discrete random variable is one that takes on a set of distinct values. You could list them out, even if the list never ends. A discrete distribution is a function that assigns a probability to each possible value of that random variable. Here is the notation we use for this function. This means the probability that the random variable x takes the value a sub I. Now here are the 2 rules that make this a valid probability distribution. First, every probability must be between 0 and 1. Second, and this is the big one, if you add up the probabilities of all possible outcomes, you must get 1. That's not optional. If they don't add to 1, it's not a probability distribution. To recap, a discrete distribution is a list of possible values, a probability attached to each one, and the guarantee that all those probabilities add up to 1. Earlier we said there's one case that's the odd one out, a subtlety. It's now time to visit this example. Imagine there's a guessing game where a computer randomly picks a positive integer. The probability of picking one is 1/2, or 50%. The odds of selecting a 2 are 1/4, or 25%. The chance of picking a 3 is 1/8, or 12.5%. Do you see the pattern? You can write the probability of picking any number as this. If you add up all these probabilities, even though they are infinite, they still sum to 1, or 100%. So this is a valid probability distribution. But is it discrete or continuous? Earlier, we said there was a subtle exception that we'd talk about later. It's now later. We said discrete distributions are for random things with a finite number of outcomes, whereas continuous distributions have an infinite number of smoothly varying outcomes. The technical difference lies in that phrase, smoothly varying. You see, there are an infinite number of points on a dartboard, just as there are an infinite number of positive integers. But these are two different infinities. In fact, there are more points on the dartboard than there are positive integers, even though they are both infinite. This is neither the time nor the place to talk about degrees of infinity, so we'll leave it like this. If you can list the outcomes, even infinitely many of them, and assign a probability to each one individually, you're dealing with a discrete distribution. If the outcomes vary smoothly across a continuum, you need a different tool. You don't assign probabilities to specific outcomes, you assign probabilities to ranges. That's where continuous distributions come in. At this point in the video, there are two possible outcomes. 1, you want to learn more and need something to click. 2, you have already left the video and aren't even watching this. You look like an outcome number 1 kind of person. You're in luck. Click the link below to visit Socratica.com and keep the learning going.